We're going to continue our discussion of solving quadratic equations by using the quadratic formula. But this time we're really going to hone in on identifying the number and type of solutions for each of our quadratic equations. And this is called using the discriminant. Now, the discriminant is the involved piece of our quadratic formula, which is b squared minus 4ac. So that is the discriminant. Now, the discriminant tells us if we're going to have real solutions or non-real solutions. So remember, the discriminant b squared minus 4ac is the part that is underneath our square root. So if the discriminant is less than 0, that means it's negative. The square root of a negative is going to result in non-real or imaginary solutions. So for example, with 2 times x squared minus 3x plus 5 set equal to 0, b squared minus 4ac, well, b is negative 3, so negative 3 squared is 9, and then minus 4 times a is 2, and c is positive 5. So we're going to be subtracting 4 times 2 times 5, which is 40, and 9 minus 40 produces a negative number, which is why our solutions will be imaginary. The square root of a negative is imaginary. Now, if our discriminant is equal to 0, we're going to have one real solution. But remember, every quadratic equation has 2 solutions, so this means we're actually going to have one solution that happens twice. This is also known as a double root. So for x squared plus 6x plus 9 set equal to 0, b is 6, and 6 squared is 36. A is 1, c is 9, and 4 times 1 times 9 is also 36, which produces an outcome of 0 for the discriminant. And remember, the square root of 0 is 0, and negative 6 plus or minus 0 gives us negative 6, and negative 6 divided by 2 is negative 3. So we have one solution of x equals negative 3, which actually happens twice, and I want us to see why that is so. If we think about x squared plus 6x plus 9, this actually factors. And the factors of x squared plus 6x plus 9 are x plus 3 times x plus 3. So can you see that we'll have a solution of x equals negative 3, and it happens twice? And then our last one, I like to get a little bit more specific than this. If our discriminant is positive, that means our solutions will be real. But remember, they could be real and rational, or they could be real and irrational. And we'll talk about the difference between those two. Notice for this example, our discriminant is 57. And 57 is positive, so it says our solutions will be real. But 57 is not a perfect square, so it says our solutions will be irrational. I can't do anything with the square root of 57. So for each of the examples we're going to look at, we are not going to be solving these quadratic equations. We're simply trying to figure out the number and type of solutions we're going to have, and that is by identifying the discriminant. So the discriminant is found by identifying a, which in this case is 3, b, which is negative 5, and c, which is 4, and determining what b squared minus 4ac actually is. So we have negative 5. Notice I'm putting that negative 5 in parentheses because I'm squaring that value, minus 4 times a times c. And negative 5 squared is positive 25. minus 4 times 3 is 12, and 12 times 4 is 48, and 25 has a value that is less than 48. Therefore, we have a negative, which means we're going to have two solutions, but these are going to be both imaginary. Remember, the discriminant is the piece underneath our square root, and a square root of a negative is not real. We have two imaginary solutions. For our next example, we need to identify the number and type of solutions by identifying A, B, and C, and determining the discriminant. The discriminant is b squared minus 4ac. So we have b, which is negative 7 in parentheses, squared, minus 4 times 6 times 2. Now, because A and C are both positive, we again have the possibility of having imaginary numbers because we're subtracting a positive. We don't know if this is going to result in a positive number or a negative. It all depends on what b squared is and how it relates with this 4ac. So negative 7 squared is 49, minus 4 times 6 is 24, and 24 times 2 is 48, which results in a positive 1. So this tells us, because this is positive, that our solutions will be real. Now, I like to take this a step farther, though. Note, positive 1, it's not just positive, it is also a perfect square, because 1 times 1, 1 squared, is 1. So that means our solutions will not only be real, but they will be rational, because the square root of 1 can simplify to be 1. Our next example, we have the negative of x squared minus 5x plus 4. So we're going to note that a is equal to negative 1, b is equal to negative 5, c is equal to positive 4. So b squared minus 4ac gives us negative 5 squared minus 4 times negative 1 times positive 4, which means right here, right now, I know that we are going to have two real solutions. Now, how do I know my solutions are going to be real? The reason I know this is a negative squared is a positive, and I have minus a negative, and subtraction of a negative becomes positive. So this is plus 16, which results in 41, and 41 is a positive number, so that reconfirms that my solutions will be real. But because 41 is not a perfect square, that means our solutions will be irrational. Our next example, number and type of solutions here, where a is equal to 1, b is equal to negative 4, and c is equal to positive 4. So for our discriminant of b squared minus 4ac, we have negative 4 squared minus 4 times 1 times 4. And negative 4 squared is 16, minus 4 times 1 times 4 is also 16. which is 0, which means we will have one real solution. And this is again what we call a double root. One solution that happens twice. For problem number 5, we have quite a bit of work we need to do in order to be able to determine the number and type of solutions we have. So we need to clean this up and we need to get it in general form so that we can identify A, B, and C. So we need to distribute and combine like terms. So distributing, we have 3 times x squared minus 6x equals 5x plus 4. But remember, we need to set this equal to 0. And so we want to leave our 3x squared alone. It's in good position. Minus 6x. We need to combine this with this 5x and get them both on the same side. So we're going to subtract the 5x. And we need to set this equal to 0. So we need to also subtract the 4. So we have 3 times x squared minus 11x minus 4. And now we can identify A, B, and C so that we can determine the discriminant, which is b squared minus 4ac. So b is negative 11, and we're going to square that, minus 4 times a times c. So negative 11 squared is 121. And is this going to be plus or minus? So we have 4 times 3 times negative 4, which is negative 48, but we're subtracting that, so that becomes plus 48. And 121 plus 48 is 169. So because this is positive, this is going to tell us we're going to have 2 real solutions. But I'd like you to take it a step farther. Is this a perfect square? Yes or no? If you were to put this in your calculator, the square root of 169, is that going to give you an integer? Or is it a non-repeating, non-terminating decimal? So 169 is a perfect square, isn't it? It's 13 squared. And so that means we're going to have 2 real rational solutions. Now you have several questions where you're asked to determine the number and type of solution. So for each of these, you are going to identify A, B, and C in order to determine the discriminant. And then you're going to have one of 4 categories. Either you're going to have 2 real rational solutions, or you're going to have 2 real irrational solutions, or you're going to have 1 real solution, or you're going to have 2 imaginary solutions. So you're going to do that for each of these questions. The first question, determine the number and type of solutions for 4 times x squared plus 3x minus 14 equals 0. For question 2, number and type of solutions for 6 times x squared plus 13x equals negative 2. And for the third question, number and type of solutions, for 3x times x minus 2 equals 2x minus 8.